Hello again. We've been working with derivatives of inverse functions in class, and I want to run through a couple of examples. I'm going to do number 3 in a couple of different methods so that we can take a look at two ways to arrive at the same derivative for the inverse function. When we're using the formula, remember that formula for the derivative of an inverse function is 1 over f prime of f inverse of x. So this is the formula we're going to work off. And to do this, we need two things. We need f prime of x, which I'll do right here. And that will be the derivative of this thing. Running this through the chain rule, I'll have 1/3 times 2x plus 2 to the negative 2/3 times 2. And if I clean that up a little bit, I'm not going to clean that up a little bit. I'll put the 2/3 there, but I'm going to leave it with the negative 2/3 power for now. When I figure out the inverse function, I'm going to plug it in right there, right? That's what this is saying. So now we go ahead and find the inverse function. I'll do that in red. The inverse function is going to be x equals the cube root of 2y plus 2. And I'm going to solve for y, and I'll end up with x cubed equals 2y plus 2, so y equals x cubed minus 2 over 2. Did I miss a negative sign? Nope, I think I've got everything here. Having a little brain issue for a minute, but we're good. So this is f inverse of x. And so now to finish off the problem, I'm going to write 1 over f prime, which is this 2/3 of 2 times my inverse function, which is x cubed minus, that's supposed to be x cubed minus 2 over 2 plus 2. To the negative 2/3. So there's a few things going on here. First of all, we can do a lot of simplifying inside these parentheses. This 2 and this 2 will cancel, and I'll have x cubed minus 2. And then that minus 2 and the plus 2 will cancel. And so in the parentheses, all I end up with is x cubed. The other thing going on is I have this 1 over. So what that does is that's going to flip over this 2/3 and make it a 3 over 2. And it's going to change this exponent to a positive exponent. So I end up with 3/2 x cubed to the 2/3. And to finish this off, I just multiply the exponents, and that makes x squared. So this derivative of the inverse function is really just 3x squared over 2. And our method, oops, I made a little whoops there. Our method for finding this 3x squared over 2 was simply to use our inverse derivative formula. 1 over f prime of f inverse of x. Okay, so that's one method for finding this derivative of the f inverse, right? Our job was to find this thing, the derivative of f inverse given f of x. I'm going to show another method, which we've also been working on, which involves implicit differentiation. So I'm going to attack this problem again. I'm going to write out the inverse function, x equals the cube root of 2y plus 2. I'm writing this implicitly here. We'll do implicit differentiation and get a formula. and then I'll show you how we can turn that formula into the same answer that we had in the last problem. Keep in mind that we figured out that f inverse of x was x cubed. That's supposed to say x cubed minus 2 over 2. Okay, so here we go. Let's do implicit differentiation. So the derivative of x is 1. I'll need to run through the chain rule on this thing. So that would be 1/3 times 2y plus 2 to the negative 2/3 times the derivative of 2y plus 2, which is 2 dy dx. And this 2 and the 1/3 can be multiplied together. They're constant multiples, right? So I have 1 equals 2/3 times 2y plus 2 to the negative 2/3 times dy dx. So to isolate dy dx, I'm going to divide both sides by this factor here. And that ends up being the same math that I did on the last slide. So I'm basically going to have dy over dx equals 1 over 2/3 times 2y plus 2 to the negative 2/3. And when I do the reciprocal, that's dy over dx equals 3 over 2 times 2y plus 2 to the 2/3. And then what we'll do, remember, this is our inverse function. This is y, not this y, but this is the y in our inverse function. If I plug that back into the function, I'll have dy over dx equals 3 over 2 times 2 times my inverse function, which is, oh goodness, x cubed minus 2 over 2 plus 2 to the 2/3. And remember, just like last time, we got a bunch of stuff that cancels. This 2's are going to cancel, these 2's are going to cancel, and the x cubed to the 2/3 becomes x squared, and I end up with the same answer, which is good. 3x squared over 2. That's exactly what we are supposed to find. Regardless of what method we use, we should end up with the same formula. So this method uses implicit differentiation to solve for dy dx and then plug the inverse function in. The other method uses the formula that we set up for inverse functions. So hopefully you can decide on one method or the other. I actually prefer the first method, but I know that some of you have been using implicit differentiation, and I wanted to show that it was possible to use that. The last example I want to work on is showing you how we can find the value of the derivative at a specific point. So for these problems, we're supposed to find f inverse prime of a. In other words, the derivative of the inverse function with this value plugged in. Now a is an x value of the inverse function, meaning it's a y value for the original function here. And the first thing we'll need to do is figure out this x value. And we've discussed in class how you have a couple of choices. One is you could set the function equal to 4 and solve. You could also do guess and check, but I'm going to write down what it should look like. X squared plus 3. And either by guess and check or by solving, you should be able to see that x is going to equal 1 here. All right, remember, x has to be greater than or equal to 0. So now I know that on the original curve, I have the point 1, 4. That means that on my inverse function, I have the point 4, 1. And that's good to know because that tells us that f inverse of 4 equals 1. And we'll need that for our formula. So here we go. F inverse prime of 4 is going to equal 1 over f prime of x, and I can quickly see that f prime of x is just 2x plus 0. So I'm going to take f prime of x, so 2 times the x, and the x in this case is going to be 1. Sorry, I got stuck at the inner limit. So, right, oops. Let's try that again. Yeah, this is going to be a 1 here, right? That's f inverse prime, or f inverse of 4, excuse me, and that's what goes in the parentheses of the formula. So we're done. We have computed the slope at that point on the inverse function to be 1/2. That is the value of f prime of a when a equals 4 for this function. F inverse prime of a. It's the derivative of the inverse function with 4 plugged in. Having all kinds of issues with this video, but I did arrive at the right answer, so I hope you give me at least credit for doing that. Again, if you have any questions, please let me know. Keep up the good work, and I'll see you soon.